exponential function and what is different logarithmic function, and basics of this, because just like we understood inverse trigonometry, we have to understand these functions as well as. Okay, that is, what is exponential function? If a mathematical function with the formula f of x is equal to some constant to the power of another variable, or a variable to the power of variable in the exponential format, such a function is called exponential function. Okay, so by using, if the base is e, that is e power x, but it can be something else as well, like b power x, right? How to differentiate them and how this is connected to logarithm. So sometimes what happens, we have to find a power of something which may be in fraction. If it is a perfect square, perfect cube, or even a perfect power, it's fine. But what if it is a power is in fraction? It's very difficult to solve them, right? That is where we bring logarithm into picture. Can you recall what is logarithm and how are we using it? A simple connection I'll tell you between logarithms. So if I have a number, just quick recap of logarithmic functions. Okay, if I have a number a power x is equal to b, okay, I can apply logarithm. Or if there is a function like logarithm of a to the base b is equal to c, it is indirectly what power of base is going to be b only, what power of b is going to give you a, and that power is nothing but c. B power c is equal to a. So finding that power, we can use the logarithm, right? Are you understanding? In both the logarithm as well as the exponential format, base is common, that is b. Okay, and we have this expression, we have this formula logarithm of ab to the power of c, right? Product can be written as what? Logarithm of a to the base c and logarithm of b to the base c. Similarly, logarithm of a fraction a by b can be written as what? Logarithm of a minus logarithm of b. One more, logarithm of a to the power of b can be written as b times logarithm of a to whatever the common base we have. Okay, if I bring the base as c, everywhere I'm going to have c. And logarithm of a number to its same base is always equal to 1. And logarithm is not defined for negative numbers, right? Remember that. So all this is fine. Now, what is the differentiation or derivative of exponential function? Let's have a look at it. So this has been proved. If you want to find the proof from the first principle, you can try that later. So let us say this is the only function whose differentiation is always equal to itself. Okay, so that's the only function which is not affected by differentiation. It remains as it is. If it is another number other than exponent e power x, if it is any other power, so then we differentiate it as a power x into logarithm of a to the base e. Remember this. And what is the differentiation of logarithm? A logarithm of function, its differentiation is 1 by x. Okay, so this we are going to use now in the next section. Shall we quickly go to the questions and solve examples on this? Yes. Yes. See, how are we solving this? Differentiate e power cos x with respect to x. So what happens is we are going to use a chain rule. First, we are going to differentiate this as it is e power cos x and then d by dx of cos x. Am I right? Yes. So e power cos x remains as it is. And what is the differentiation of cos x? Minus sin x. So final answer is minus sin x into e power cos x. Now another example with a logarithmic function. Differentiate sine of log x, a composite function with respect to x. So first we'll differentiate sine. Sine is cos of log x and then d by dx of what? Log x. What is d by dx of log x? 1 by x. So our answer is 1 by x into cos of log x. Simple. Isn't it simple? Yes. Shall we solve some questions? Yes. Yes, shall we solve? Yes. I have around 7 questions. And again, another assertion reasoning. Shall we quickly look into the solution and do the reverse process now? Or you want me to solve the first? Let's solve it then. Assertion, I don't have time to read all this, so let's go to the solution directly. So d by dx of e power sine x, is it correct? Is the assertion correct? How do you differentiate with the chain rule? d by dx of what do we have? Let me erase this. d by dx of e power sine x will be equal to e power sine x and cos x. Yes, assertion is correct. As assertion is correct, option D is ruled out. Okay, so the reason because of this, because it is d by exponential functions differentiation is equal to e power x. That is the reason we got this. Yes or no? That means both assertion and reason are correct, and R is the correct explanation of E. Right? Yes. Let me erase this. Let's go to the next one. Yes, differentiate this. Can you quickly do that? Y is equal to 7 into e power minus 3x plus 2 into e power 2x minus 5 into e power x. So when I differentiate, we know now how to differentiate exponential function. 7 remains as it is. E power minus 3x, because of minus 3x, we'll have minus 3 plus 2 into e power 2x as it is. Because of 2x, it is 2 minus 5 into e power x. So what is our answer? dy by dx minus 21 e power 3x plus 4 e power 2x minus 5 e power x. Isn't it? You want to verify the answer? You want to verify quickly? Yes. See, minus 21 e power minus 3x plus 4 into e power 2x minus 5 into e power x. That's our answer. Yes? Any doubt in this? No, right? Let's go to the next one. We may have to increase our speed. Now we have a combination of logarithm as well as cos trigonometric. See the combination, we have a logarithmic function, trigonometric function, as well as exponential function. So that means we have to use the chain rule carefully. Y is equal to logarithm of cos of exponential x. This is our function. There are 3 functions involved, right? Very good, very interesting one, right? So when you first differentiate for logarithm, it is 1 by cos of e power x. Now we're going to differentiate for cos. What is that? Minus sine of e power x, and then e power x remains as it is. So our answer will be e power x minus of sine e power x by cos e power x. Further, if you want to simplify this, it is minus e power x into what? Tan of e power x. Want to check this answer quickly? Yes. See this? E power x into minus e power x into tan of e power x, exactly matching, right? All the steps are exactly taken, and yes, this is the right answer for us. Isn't it? Yes. Let's go for the next question. Question number 4. So this will be the last question. I'll be going to the next section. Okay, so you can check the solution for the remaining questions from our practice questions part. Okay, so this is y is equal to 5 into e power ex cube logarithm of x. The product of 2 functions are there. So we have to make use of what rule? What rule? Product rule. What is product rule? Product of 2 functions u and v. If you want to differentiate, you will differentiate in any order, one of them first, and the other one remains as it is. Next, the reverse order. Right here, plus doesn't, I mean, here the order doesn't matter because we have plus and addition is commutative, right? But in case of differentiation of a fraction, we're going to differentiate the numerator first, the denominator as it is, minus, this order is very important, u dash v by v square. Right? So just a quick recall about product rule and quotient rule. Now let's apply this here. So dy by dx is equal to, let's keep 5 outside. Let me first differentiate e power x cube into 3x square. Let's keep the log x as it is. Plus, now I'm not going to differentiate e power x cube, but I'm going to differentiate log x. This is our, after simplifying, we may have to take 5 is anyway common, e power x cube is also common. What we end up with is 3x square log x plus 1 by x. This must be the answer. You want to check the answer? Yes. 5 into e into x power cube. Exactly, it's matching, right? That's our answer. Right? 3x square log x plus 1 by x.